Dear students, I am going to take the problems for GATE examination, which as the examination for GATE is nearing, so it would be helpful for you to solve the problems related to structure analysis. The first problem I'm going to take that suppose there is a beam and you deal here. This point is the hinge point A, B and C. W kilonewton per meter. Span is equal L and L. So how to solve this? We have to find out what is the reaction at C. Reaction at C. How much it is? Now we draw the free body diagram. How to draw the free body diagram? This will because of the hinge. Let us take the support. This will be support reaction RC and this will be the load. Now this is the extra. RC is extra, so we have to make RC here. So this will be RC. So RC neutralize. So the same it will be having, and here the bending moment will be 0 because at the free end it becomes 0. So this same the condition of this we have shown in the free body diagram. Now to find the reaction at C, what will we have to take? We have to consider the deflection. Deflection in this beam and deflection in this beam will be the same because this beam is stable, statically equilibrium condition. Therefore, deflection in AC beam must be equal to deflection in BC beam. This is the propped cantilever. So for the UDL, deflection will be downward, and for RC, deflection will be upward. For UDL, deflection is WL4 upon ATI, and for RC, L cube upon 3I, and this is also RC L cube upon 3I point load. So this will be, so WL4 upon 8I is equal to 2RCL cube upon 3AI. So RC is how much? 3 by 16 L, WL. So this is the reaction. This way you can find out the reaction at support C. If they will ask draw the bending moment diagram, then you can draw this bending moment diagram for this individually and this, and then you combine these two. In this way you can find out draw the bending moment diagram and shear force diagram. Suppose for the bending moment diagram, here you can draw it, bending moment diagram. So RC into W ln L by 2 moment at x from here, say. So moment at x will be how much? Wx square by 2 minus RC into x. So anywhere if you want to find out the bending moment, you can find out using this relation x. Suppose x we are finding out here, then it will be RC is already known. In this way you can draw the bending moment diagram. Now come for the second problem, which is from degree of static indeterminacy. Suppose and this is the hinge. You have to get the degree of static indeterminacy. degree of static indeterminacy. You have to find out. So what we'll do, there are two methods. One method is Henderson rule, other is the method of joints. I will solve this problem by both the methods. Which one you like, you can apply anywhere in the problem. Now first we are using the Henderson rule. So if on Henderson's rule, if I'm applying, then you have to make this rigid. Once you're going to make rigid, then bending moment, there will be bending moment 0. As you make the rigid, bending moment will appear. So there will be restrain is 1. We are restraining it. Here only one reaction. So there is bending moment 0, horizontal reaction 0. As soon as you make the rigid, this will be a strain fix. So here you have to apply two restraints, because you have to make tree-like structure. Then it has become tree. This is fixed. This is also rigid. Now you have to cut in such a way that it looks like tree-like. So one cut here, one cut here, and one cut here. So if you make 3 cuts, it will be tree-like. This is the tree. These two are the branches. For this is the branch. For this has fixed. So this branch and this branch. For this branch. So this is already cut it in such a way that this become tree-like structures. Then DI is equal to 3C minus R dash for plane structure. So how much 3C, how many cut we have made? 9, 3. And how many restraint? 2 and 1 here. So 3. So this is 6. So DI is 6 by Henderson rule. Now the same problem can be solved using method of joints. Let us try by method of joints. Third, method joints, this also you have to make the rigid, but support reaction will not. So this is fixed, this is fixed, this is roller, this is fixed. So what is the DI for by the method of joints? Method of joints. What is DI is 3M plus R minus 3J minus R dash. Whatever the restraint to make the rigid, you have to subtract it. So how many members it is? This 1 member, 2, 3, 4. There are 4 members. How many reaction? 3, 3, 6, 9 and 1. 10 reaction. How many joints? 1, 2, 3, 4, 5 joints. Unrestrained 1. By 16. 6. So by method of joints also DI is 6. By Henderson rule also this is DI is 6. This is total indeterminacy. If you are external indeterminacy and internal indeterminacy. External indeterminacy will be R minus 3. So 10 minus 3 is 7. So internal indeterminacy is total minus, so this is minus 1. So this is the internal indeterminacy, and this total is 6. This way you can find out the degree of indeterminacy of a frame structure. Now let us take another example of determination of static indeterminacy. And two-story building, this is hinge, this is hinge. So this is also hinge. So now we are going to find out how many. First I am use the Henderson's rule to find out the degree of indeterminacy. For Henderson rule, you first make the rigid. So one here and one here. You have to make tree-like structure. So here there are two reactions. If you are making, then one here. Here one reaction only. If you are making fixed, there you have to add two. So after this, this become fixed, this become fixed, this is rigid, this is rigid. Now it is a fixed support and all. Now you have to cut in such a way that it becomes tree-like structure. So one cut here, one cut here. So we are applying two cuts. Now Henderson rule di is equal to 3c minus r dash. 3 into 2 minus r dash. 2, 3, 4, 5. There are 5. So only one is indeterminacy. Total indeterminacy is 1. Now we can apply the method of joints. The same we can apply the method of joints. Now it will change. So this is also 1, this is 1. Now support reaction here is 2. Here is 1. So 3 support reaction. External determinacy is 0. Only there is internal indeterminacy. So how much? Now you have to find out by method of joints. Method of joints. I am applying. So what is di? Degree of indeterminacy 3m plus r minus 3j minus r dash. How many members? 1, 2, 3, 4, 5, 6. There are 6 members. 1, 2, 3, 4, 5, 6. There are 6 members. Reaction, 3 reaction. How many joints? 1, 2, 3, 4, 5, 6 joints. Minus 2. So this or this cancel. 3 minus 2, 1. So here also it is coming 1 by method of joints. Total indeterminacy is 1. So external indeterminacy r minus 3. So r is 3, minus 3 is 0. So internal indeterminacy 1. So this is the total. Okay. 1 minus 0, 1. So total indeterminacy is 1. In this way you can find out for this problem. Now I am taking another problem for this same, so that you must have variety of problems. Now this is the hinge. Hinge. So you have to make, if I apply the Henderson's rule, then you have to make the rigid rule. But the R dash is nothing but sum of the members meeting at Z joint minus 1. How many members meeting here? There are 1, 2, 3, 4. 4 members are meeting minus 1, therefore R dash is 3. Now you have to cut to make tree-like structures. One cut I am making here, one cut here, one cut here, and one cut here. There will be 4 cuts, and R dash is 3. Now very easy to find out. Therefore 3c minus R dash. C is how much? C is 4. How dash 3? So it is 9. Now you can apply the method of joints. If I apply method of joints, R dash is 1, 3. Now if a method of joints, so di is equal to di is equal to 3m plus r minus 3j minus r dash. How many member? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There will be the 10 members. 3 into 10. 3, 3, 3. 9 minus how many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9 joints. Minus 3. So how many? 9. This and this cancel to 9. So total indeterminacy is 9. So external indeterminacy here is r minus 3. So r is 9 minus 3, 6. So internal indeterminacy total minus 6 is equal to 3. So there will be external indeterminacy 6, internal indeterminacy 3. In this way, this problem has been solved, and we get by both the methods we are getting the same value. Now I am taking different type of problem in a continuous beam. Suppose this is a continuous beam and here you are taking roller and UDL is there, A, B and C. So dW kilonewton per meter, this is L or EI, this is also L or EI. Now the question is, what will be the central deflection? Central means B. What will be central deflection if reaction at E is 0? So how you can solve this problem? What will be the answer? If the reaction here RB, if it is 0, 0 means there is no reaction. So this become just like a simply supported beam with UDL. Length is twice L. Now the central deflection, you have to already know the formula for this. How much is central deflection? WL4 upon 8EI. This is the deflection. So WL4 is 2L. 4 divided by 8EI. And this is equal to 16 WL4 upon 8EI. This is 2 WL4 upon EI. So this is the answer of this. You will be asked to how many will be deflection. So this must be the deflections. Now come for the next problem. Next this is fourth problem. Now this is the fifth problem. Suppose there is a beam here and suppose a point here I'm seeing C at a distance A from here. Total length is L. A, B. The question is, what will be the deflection at, here there is a couple, mu kilonewton meter. What is the deflection at B? How many deflection at B is? How to solve this problem? So first we idealize, you can solve by conjugate beam method very easily. Now how to conjugate beam is, we draw first the bending moment diagram for this conjugate beam. How to make the conjugate beam? It will assume as, so this is the mu. If I draw the bending moment diagram, this is the, because here there is no load, only here is there, that moment will be transferred. This is the value of the bending moment diagram. Now to make conjugate game, you have to divide by EI. So EI से divide कर दिया हमने, that it will be divided, and the free end you make fix. Now the deflection, and say this is A dash and this is B dash. This is the conjugate beam. It has been converted into conjugate beam, and this bending moment is converted into a elastic load. Once it is divided by EI, it will be converted into a elastic load. Now as per conjugate beam, the bending moment at the B end, B dash, is nothing but the deflection in the original beam. Now I have to take the bending moment. So bending moment at B dash is nothing but deflection at B. So how to find out bending moment? This is the load. So load means area. Area is mu by EI into A. This is the area. And CG distance will be half. So total is L minus A by 2. So this is the deflection at B. Mu A divided by EI L minus A by 2. This is the answer of this. You have to find out the deflection at B. You take the bending moment at that point of conjugate beam. So this will be. Now take this beam. You are taking this beam, frame beam of the distance A, B, C, D, E, A. The distances are 1 meter and 0.5 meter. So first what you do, the bending moment at E find out. 10 into 0.5, that will be 5 kilonewton meter. Now here is the anti-clockwise moment 5 kilonewton. To balance here there will be a clockwise moment, and to balance this there will be anti-clockwise moment. So here a clockwise moment, then anti-clockwise moment at clock. So in this way there will be same value will be at A, and the value is minus 5 kilonewton meters. So this is the answer, 5 kilonewton meter for this problem. I think this problem is 6. Now we can take the another problem, 7. This is L. This is L. Let's say C, A, B, C or D. What we have to do? What we have to find out for this? For the deflection, vertical deflection at B is 0 if vertical deflection at B is 0, then A by L is equal to what? We have to find out A by L is equal to how much. So what do you do first? Let us find out the free body diagram of this. Do the free body diagram. We can go for the. Now I'm drawing the free body diagram. So this is W. So balance this, there will be a W. So here there will be, this is W. So here there will be W. Then come for this beam. Downward, then this will be upward. No, this will be downward, this will be upward, and this will be downward. This will be downward. Here to balance it, there will be a downward load. To balance it, there will be here upward load. And to balance this, there will be downward load. And this is fixed. And there will be a moment. Moment is how much? W into moment at C. W into A. So W A is the moment, and that is the clockwise moment. So finally, if you draw, this will be a moment clockwise, W into A, as well as there is a load W. Then we have to find out if the deflection here is 0, then what will be the value of AIL? So deflection for point load will be WLQ, this is the L. So there will be two deflection. One is for point load, other is for moment. So deflection for point load WL cube upon 3I. This will be a clockwise moment if I am going to here, and this is anti. So one will be positive, other will be negative. W into L here, if देखिए clock, anti-clock, and this is clockwise. So one will be positive, other will be negative. For moment, we already know that deflection will be here, this much. So delta B. So this is WLQ upon 3I. What is the value of M? W into A. W into A, L is square upon 2EI. And this is 0. L cube upon 3I minus WA, L is square upon 2EI. So L by A is equal to, A by L is equal to, if you solve it, A by L is equal to 2 by 3. This is the correct answer. A by L is equal to 2 by 3. So in the problem you will be given A by L is 2 by 3, 1 by 3, 6, 1 by 5, 1 by 3. Whatever it will be, your answer is A by L is 2 by 3. Now take another example of a complicated type of beam. This is 3 kilonewton, 1 meter, 3 meter, B, C, D, or A. Okay. This is nothing but a rigid link. This is not beam. Suppose this is the beam. This is the beam. So this is the link, a rigid link. So if the load is here, there will be tension in this. So you have to make tension like this. This is the tension. Say T is the tension in that. So now you take the free body diagram, and here is the T. Here is 3 kilonewton. This is E point, this is D point, and this is A point, or C point. This is C point. Now you can find out the bending moment at C. What will be bending moment? Because it is simply supported beam, so the bending moment is 0 here. Now this is a clockwise moment. How much? 3 meter and 1 meter. So 3 into 4 clockwise, and this is anti-clockwise moment, T into 3. Analysis is 0, 12 minus t into 3. This implies that t is equal to 4 kilonewton. 4 kilonewton. What you have to find out, what is the moment, what is the moment at A? Moment at A is how much? So moment at A is equal to, we got the 3, we got the tension 3 here, 3 and the 3 meter. So now the bending moment is 3 into 4. 3 into 4. So this is 12 kilonewton meter. Bending moment at 12 kilonewton meter. This way this problem can be solved. Now I am taking the another problem. 2 kilonewton, here is 1 kilonewton horizontal. This is A, B, C, D and E. This is 1.2 meter. You have to find out what is the bending moment at C. What is the bending moment at C? How you can find out? Because of this simply supported, you can taking moment about B. Moment about B. So there is the reaction RA. So RA into 3 by 2, RA into 3.2 is a clockwise moment. And there will be, this load is 2 kilonewton load is exactly over the B, so that there will no moment will be 1 kilonewton. And this is a clockwise, this is anti-clockwise, this is clockwise. So minus 1 into 1.2 and that will be 0. We can find out the reaction. Reaction is how much? 1.2 divided by 3.2. So this is 3 by 8. RB will be how much? RA plus RB is how much? 2. RA plus RB, only 2 kilonewton. So RB is 2 minus 3 by 8. So this is 13 by 8. So now you have to find out what is the bending moment at C. So RA into 3.2, 1/6, 4.8, and this is also plus RB into 1.6. So RA 3 by 8 into 4.8 plus 13 by 8 into 1.6. So this is coming as, and both is minus because they are anti-clockwise around it. So the value is 4.4 kilonewton meter. One moment at point C is 4.4 kilonewton meter. Now I can take the another example. And this is 4 meter. A, B, C, D. And if I'm going to so 80 kilonewton is a clockwise moment here, 80. So anti-clockwise will be here, anti-clockwise, so clockwise here, and then so will be anti-clockwise here. And so to balance it, there will be a clockwise moment here. Finally, on A, there will be a clockwise movement, and the load here, the 20 kilonewton load, so here will be 20. Now in this member there is 20, so here is 20. Now in this, then in this member there will be 20. So here the load is 20 kilonewton and member. Finally, if you see, this will be a moment and a reaction. So this is 20 kilonewton, this is 80 kilonewton meter. One is clockwise, there is, so bending moment at A is 20 into 2 minus 80, so this is 40 kilonewton meter, 40 kilonewton meter. In this way, this problem can be solved. Very important for that. Suppose this is the beam and there will be load P, and here the load is Q, length L and L. So your problem is, what is the value of P by Q is how much? When deflection at C is 0. We have to find out the ratio of P by Q when deflection at C is 0. So to solve this problem, you always, such type of problem you solve by conjugate beam method, which is very easy to solve it. First I am taking this load P load. How many will be the deflection at C? Deflection at C is equal to P into 2L cube by 3I PL cube upon 3. In this case, the L is twice L. So this will be 8PL cube by 3I. Now you take the second one. Now you can take the second one, and second one is this much, here Q. So now you draw the bending moment diagram. Bending moment diagram will be this Q into L, QL divided by AI, it becomes conjugate beam. This converted into elastic load, and this point is, this is C, so this is C dash, and free end becomes fixed end. Therefore deflection at C in this case is nothing but bending moment at C dash. So this will be, how much is the load means area, so half into QL by EI into L. This is the load. What is CG distance? Total is 2L minus, this will be from this side, it will be L by 3. L by 3. QL is square upon 2EI into 6L minus L. So 5L by 3. So this is equal to 5QL cube divided by 6AI. Now the total one is downward load, other is upward load. One will be positive deflection, other will be negative deflection. Therefore, net deflection at C is equal to 8PL cube upon 3EI minus 5KL cube upon 6EI, and it is 0. Therefore, P by Q is equal to 5 by 16. Five by 16. LQ cancel. So this way you can find out the ratio of P by Q when deflection at C is 0, then the ratio of P by Q will be 5 by 16. Taking the same beam, but the condition is different. In this condition, P by Q you have to find out if slope at C is 0. Now I am taking the beam first load P, draw the bending moment diagram. This will be P into 2L. So 2PL divided by EL will conjugate beam, and this will be a C dash. So area of this conjugate beam will get the slope. The slope at C is nothing but area of this. So this is the area. Similarly, I am using the Q here, B or so here also the slope, we can find out the slope will be the area of this. So same slope will be continued to C dash. The slope at B dash is nothing but slope at C, because the same slope will give you. The slope at C, the area of this. Now you take one is clockwise, other is anti-clockwise. They are equating to, and P by Q is 1 by 4. In this way, we can find out the ratio of P by Q if slope at C is 0. In the next video, I will come with few new problems for the GATE examination. And till now, good night.